Hello everybody, this is Pong, and I just finished a coding challenge where I programmed exactly this. And this is working Pong with very few bugs. It probably has some bugs I haven't noticed yet. However, I had a lot of problems making this video. I was so excited, like here it is again, I'm gonna have the greatest video ever on the internet. It's gonna be 10 minutes of making Pong, and everyone will just be able to watch it in 10 minutes and make their own versions of Pong to creative delight of children everywhere. But I failed. First of all, the video is at least an hour long. It's going to be longer now that I'm with this rambling introduction. I had a lot of problems and things I couldn't figure out. And I want to say that there was a major issue. At a certain point later in the video, I used this function to kind of look at how I can map an angle to a direction. Because based on where the puck hits the paddle, it should move in a certain direction. And I forgot a couple things. I didn't actually convert to radians when I was doing that test, and the range that I used actually went in the wrong direction. So those things will be wrong in the video. The code, however, that you see linked in this description has the corrected version and is what you see right here. There's some sound. Let me turn that off, and I can move. I'm going to play this a little bit more. Right now my left paddle is doing much better than my right paddle, but I made it. I made Pong. I hope you will do creative versions of it, and I'll see you in another video sometime. Enjoy this coding challenge. Hello! Welcome to a coding challenge. I am super excited for this one. It's been a while. People have asked me to do more coding challenges with a timer or simple games, and I'm going to program in this coding challenge Pong in 2 minutes and 30 seconds. No, definitely not. It's probably going to be like 3 hours. But you can see how long this video is, and then you'll know about how long it takes. I'm not stopping in the middle of this. It doesn't matter what bugs or things I can't figure out. I am going on. But I'm not starting my timer just yet. What I'm going to do before I start a timer is let's at least together, you and me, map out the pieces of Pong. Figure out what features we're going to implement. So if I have a computer graphics window, a canvas in a browser or some other kind of graphics window, what I need to have are two paddles. I need a left paddle and a right paddle. And then I also need to have a puck. The paddles move up or down based on keyboard input. So maybe like we'll do, I'm gonna look over at a keyboard, like, you know, A and Z and K and M or something, you know, whatever. So it could be played on one keyboard. I mean, obviously, one of the reasons I'm doing this is later I might make a video to look at some different artificial intelligence algorithms that might allow us to like see if we can have the computer play one of the paddles, but that's an aside. So I need the puck, and the puck needs to have an X and a Y, and it also needs an X, I'll call it X speed and a Y speed, because it needs to figure out which way it's going. I need to have some type of collision detection between the paddle and the puck. And then I also need to figure out if the puck goes past either side, there's a score. So this player gets, you know, +1 score if the puck goes past the opposite side. It's like air hockey. It's Pong. Okay. Are we ready to do this now? Here's the thing. Have you ever programmed before? If not, you might have a little trouble following this video. But I'm going to try to keep this fairly beginner friendly. I'm going to use a programming environment called processing. You can learn more about processing in this video's description. And I'm going to use a concept called object-oriented programming, meaning I'm going to think of the puck as an object and each paddle as an object. And the puck is going to have data associated with it, like its location and its speed, where it's moving. And there's going to be functions like, does the puck hit the paddle? So those are the things I'm going to add to the program. I will also make a JavaScript version that you can run in the browser, so you can look in this video's description for that code as well. I'm trying to say all this stuff out now, because I know I have to get started in a second. What else am I forgetting? I think I can just get going now. Okay, I'm going to walk over here. That's where my computer is. All right, now I have this timer going up there. It says 14 minutes. Oops, I'm in the wrong program. Here we go. This is processing. It's got a setup and a draw function. I haven't started yet. Don't look at the timer yet. I'm going to hit refresh. It'll go back to 20 minutes. I'm procrastinating. I'm going to do this. How long is this? It's already like 5 minutes long, probably. Let's just get started. Okay, ready? Here we go. 1, 2, 3. Okay, Pong. All right. Oh no, I'm panicking. Okay, first let me just add a background. I'm gonna make a background that is black. The puck is I want the puck to be. I'm just gonna make it a circle. because that'll be easier to deal with. So let's just get started. Oh, and let me save this. Save Pong. I'm going to add another tab here in processing, and I'm going to call that puck. And the way object-oriented programming works is I create something called a class, and a class is a template for making things. So this is the puck template, and I need to make an actual puck. So the template is going to have an X, and it'll start in the middle of the window, and the template, the puck, is also going to have a Y, and it will start also in the middle of the window, and it's going to have a function. I'm going to call it show, and I'm going to, in that function, I'm going to say fill 255 ellipse X, Y, and I'm just going to give it some arbitrary size, 24, 24. So the ellipse function draws a circle with, and how's the font size? Is the font size okay? Can you see it? Okay, so let's now go and run this. Oh, well, now let's make a puck. So now I can say puck, puck, puck equals new puck, and puck dot show. Is that the right thing? Is it called a puck? I don't know what it's called. Here we go. Ta-da! Am I done yet? No. So now we need that thing to move. So for it to move, I'm going to give it, I probably shouldn't. No, I'm going to say x speed equals, I'm going to make this a random number. So I can use the random function. I'm going to say random -3, 3. There's a lot of things about this that I should be using vectors for. And y speed is -3, 3. Here's the problem. I don't actually want to do this. Oh, it's so sad. But let's just leave it this way. I can improve this later. I don't like this because I could get a puck that's not moving at all. Let's just give it a fixed. Let's just give it a fixed speed, 3, 1. It's always going to move the same way. I'll fix that later. Void update. I'll call this. I'm going to write a function called update, and in update I say x equals x plus x speed, y equals y plus y speed. Okay. So now if I run this, it doesn't do anything. But if I say puck dot update. Now I'm calling that function. Draw, by the way, is the thing that happens over and over again. Update show, background update show, background update show, background update show. I should not be singing. It takes up too much time. There we go. There we go. So now, oh, we're going to need some paddles. I strangely want to do something that I wouldn't normally do. But before I do the paddles, let's implement some other parts of the game. So let's write a function that's called edges. So really, we have to worry. What happens if the puck hits the top or the bottom, right? So if y is less than 0, then I need to reverse the y speed. So y speed times equals -1. And actually, I'm going to do this if y is less than 0. And this, by the way, is a symbol in programming for or, in Java programming or processing, also JavaScript, 2 of these pipe symbols. Or, if it's less than 0, meaning it's above the window, or greater than height, meaning it's below the window. Reverse the speed. And let's be sure that this is doing that by kind of giving it a very kind of initial, oops, wrong thing, wrong. Let's just test this by saying, giving it a very slow x, but a fast y. That didn't work. Oh, I have to call it. So I have to say puck.edges. So I can write a function that gives it some logic to follow, but if I don't call the function, it doesn't do anything. So okay, so that's working. It's going to bounce off the top and the bottom. It does that in Pong, right? I think it does. Okay, great. So now let me go back to something more reasonable. So now I also want to check, though, if x ever gets past the window, then what I want to do is I want to say, I want to like reset the puck. If x is greater than with or x is less than 0. I want to reset the puck. Now here's the thing. I need to track both of those separately because different players are going to win. But let's just make that 2 separate if statements for later. But let's just call reset right now. And reset, so reset is going to be a function that I'm putting inside this object. And what does it do? It sets the puck back to the center. And you know what I'm going to do? I'm not even going to change its y speed or x speed. I'm just going to let it be the same, which is I should probably have. So now we can see here's what it's doing. If it gets past the right-hand side, Okay, so that's actually a problem because it's always going to go the same way. But okay, so we've got the puck moving. Yeah, I didn't, James in the chat writes, you didn't take into account the ellipse size, so it's going to clip on the edges, but not a big deal. This is a good point. I don't know if I have time for these details, but let me see if I can, I'll add that in later perhaps, or that's something that somebody watching could add. Okay, we need some paddles. So what I'm going to do now is I'm going to make an object called paddle. And again, I need a template for the paddle. And the paddle is going to get, it needs to have an X location and a Y location. And let's think of a height. And you know what? Let's use, and a width. This is a little tricky. I kind of want the paddle to be maybe using the reference point. Well, let's just, we're going to do what we're going to do. Okay. X and Y. Why is my, okay, stop. Everything's buzzing. Okay. I turn off notifications before you start these things. Okay. So the other thing I'm going to do is when I make the paddle, I want to pass in a, and I'm going to call this like, I'm going to say X underscore. This is a little bit weird if you haven't done object-oriented programming with construct. This is what's known as a constructor function. So Y, so first of all, Y is always going to be, yeah, let's have, okay, so here's the thing. I need a minute. Can I take a minute? There's no way to pause this timer, but I don't get to pause. There's lots of different ways you can think about a rectangle. You can think about a rectangle as from this point with a width and a height. So this is the XY with a width and a height. You can think about it from here with a width and a height. You can even think about it based on just these two corners. I think I want to think about the rectangle strangely enough. I don't really love this because it causes some other problems, but I think it's just going to be easier for me to think of the rectangle from the center point. So I'm going to do that. So I'm back. So Y is always going to be height divided by 2. Width of the paddle is going to be like 10 pixels, and the height is going to be 50 pixels. So probably have to change those later. So, and then I want a function called show. And I need to say rect mode center. And I'm going to say fill 255 for this as well. And I'm going to say rect x, y with height. And it's, okay, now where its x is kind of a tricky thing. And you know what I'm going to do? We're going to leave this. We're gonna, there's a better way to do this, but I'm not going to worry about it right now. Okay, so let's now, in here, let's make paddle, I'm going to call it left, and paddle right. So I want to be able to use that same template to make two objects. Oh, the power of object-oriented programming. So I'm going to say left equals new paddle at 0, and this is going to be wrong. And right equals new paddle at width. And then I want to say left.show, right.show. Okay, let's run this and see what I get. No, it's not so bad. There are the paddles. They're really small paddles. So a couple things. One is, notice how, because the center of the rectangle is right on 0, actually half the rectangle is off the window, which is fine, but just for, you know, just to keep things, I probably want to say its actual location is x, wherever it was given its initial, plus its width divided by 2. Or minus, depending on whether it's the left or the right. Okay, better idea. We're going to use an argument here, Boolean left. So is it the left or the right paddle? So I'm going to make one puck true, one paddle true, one paddle false. I'm sure everybody in the chat is thinking of a lot of things that I'm doing wrong. I can't look at the chat. I don't know. Post a lot of, if there's something really major, I don't know. I don't know how to get my attention. Okay, so what I'm going to do is I'm going to say if left x equals w divided by 2, else x equals width minus w divided by 2. So I'm basically going to take a Boolean variable in because there's only two kinds of paddles. And now if I run this, there we go. And I should make these paddles taller. Let's make them 100 pixels. And there we go. So now we're pretty good. We've got Pong. Oh, someone's saying there's usually a gap between the paddles and the edges. Okay, let's add that. Plus float gap. Well, that's going to make it so complicated. That's fine, though. Actually, it won't really. X equals w divided by 2 plus 10 minus 10. Let's just give it a little, or actually, why don't I just use the full width? And the gap is however wide the paddles are. Okay, there we go. Pong. Oh, I got 9 minutes left. Okay, so here's the thing. First of all, I need to move the paddles. Oi, 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 oi. Attention, shift master, meister, false alarm. Got it. Okay, so what I need to do is move the paddles. Let's write a function called move, and it's going to move by some number of steps. So I'm going to say y plus equal that number of steps. And then I'm also going to say y equals constrain. So I don't want to let the user move the paddle off the window. Constrain is a function that says take this value and constrain it between 0 and height. Only I don't want to constrain it between 0 and height. I want to constrain it between, because x can't actually go all the way up. I want it to stop, because, sorry, y is the middle of the paddle, constrained between, I want to draw a diagram, but I'm worried about the time. I should never use these timer things. It's height divided by 2 and height minus h divided by 2. So this would now keep it, I'm going to draw a diagram, forget the time, right? Because if this is the edge, right, this is the y where it can't go up any further. And this amount is the paddle's height divided by 2. So that's sort of an important piece there. Now I have some errors here. Oh, I need a semicolon. So now how do I move the paddle? Okay, well, in processing, in addition to setup, starting the program, and draw, running the program, I can have a key pressed function. And in the key pressed function, I get an event. Every time a key is pressed, this code is executed. Am I standing in front of it? Let's move this over. So what I want to do is I'm just going to say if key equals A, I'm going to take the left paddle, and what do I call it? Move -1. That's up. Else if key equals Z, well, I realize I'm going to have a problem here. Left move 1. And now I'm going to do the same thing for, I don't know, J and M. This terrible interaction ideas, but and this should be the right one. So now let's run this. Oh, look how little it moves. So let's change this. Let's have it move 10 steps every time I press, and I should probably make that a variable. Now, I can't hold it down. Oh, I'm really going to have to fix this. Boy, I'm going to need more time. I need more time. I got to fix this now, actually. It's kind of unplayable. The issue is I can't hold down the key. So this is a problem. What I actually need to do is whenever I press the key, I need it to start moving and not stop moving until I release the key. So, so what I'm going to do, this is a little tricky, but I'm going to take key released. And in key released, basically, I want to say left, stop moving. Or actually, I can do move 0, because I have that function, right, move 0. And the difference is, instead of this actually won't be so hard. So right, what this does right now, in the move function, if I go to the paddles move function, it's actually moving it in the function. But what I want to do is I want it to have I'll just call it like I don't know what to call this. I don't have time to think about it. I'll just call it y change, which is 0. And I'll also have an update function, which does this. So the update function always changes it by y change. And the move function just sets y change to a certain value. So in other words, I'm going to always left.update, saving the hardest part for last. Left.update, right.update. So it's always moving. It's just often moving by 0. It's always moving by 0 unless I press a key. It sets it to move by a certain amount and stops once I release the key. And now I'm going to do this. So now this is quite a bit more elegant to play with. There's issues with I can't press more than one key at a time, but those things can be ironed out later. Okay, here we go. Now, I see a question. Did Pong repel in different angles depending on where it hit the paddle in the original? Ooh, the paddle was broken up into 8 slices that make the ball bounce at different angles depending on which segment the ball hits. Why? Why make this so hard? This is definitely going to take longer than that amount of time. But let's first at least get the, let me make this thing move a little bit faster here. Okay, so, why is it so slow? Okay, great. So first thing that I want to do is I want to check to see if the puck hits the paddle. This we can do. And because I'm using object-oriented programming, I can just have a little dream, fantasy state of how I might write this, right? If puck hits left, or if puck hits right. Puck, reverse, reverse. So, and actually what I want to do is, this is kind of like the idea, but you know what I'm going to do? All this can happen just in the puck itself. I can just say puck, check left, check paddle, left, puck, check paddle, right. Okay, so this is what I want to do. You can see here, it's got this red line. It has no idea what check paddle is. But the idea is that I want to write a function called check paddle that's part of the puck object that receives a paddle and checks if it's hitting it. And I have to do it do I have to do it differently with the left and the right? Kind of. Yeah, I shouldn't use reverse because that's a reserved word. Okay, okay, so let's go into the puck. I should have thought this through in advance. Void check paddle, paddle P. By the way, you'll notice here, I didn't write a constructor function. Technically don't have to, unless you have some type of logic that you need to execute in the constructor function. All I had were these set variables, so I don't need one, although, proper object-oriented programming would have me write just this blank function that would get called when I say new puck. Okay, check paddle. Check paddle. Check paddle. Okay, let's just pretend all I'm thinking about is the right paddle. If x is greater than paddle.x and y is less than paddle.y plus paddle.y. Oh boy, I'm just going to do it. Paddle.y, I don't love this. Paddle.y plus paddle.y plus paddle.h divided by 2. And y is greater than paddle.y minus paddle.h divided by 2. I hate this long, awkward if statement. There's so many ways I could probably make this nicer. But this, look at this horrible gobbledygook. But let's use the fact that there's 1 minute left to explain what I'm thinking about here. You're going to hear a ding sound. Actually, you won't if it goes off while I'm over at the whiteboard. So I have to, okay, I'm going to give myself some bonus minutes. So in other words, I want to know if the x has moved past paddle's x, but I want to know, this is paddle's y, if the y is in between paddle y minus h divided by 2 and paddle y plus h divided by 2. So that's the section that I want to look at. I want to refactor this so badly to make it nicer, but this is kind of will work. How am I on time? Oh, a minute left still. So if this is true, I want the puck's x speed to change to multiply itself by -1. And this is going to work for the right paddle. So let me just only right now check the right paddle. Let's just see. Oh, quick, move down. Oh no, move down. No. Hey, there we go. Okay. This really looks so wrong, right? Right, because you can see here. I really. First of all, it goes way past. So I really have to. I'm sorry, I'm losing. I really have to deal with the fact that the puck has a size. I'm just looking at the time. How much more time should I give myself? How about 10 more minutes? Oh my God, that was really loud. Let's give myself 10 more minutes. By the way, if you want to know how to program a timer in JavaScript, I previously did a coding challenge where I made that exact timer. Okay, 10 more minutes. Let's see if we can do that. Okay, so we've really got to deal with the fact that the puck needs an R. So its size, I like the size of it, is reasonable. I was drawing it at 24, so the radius is actually 12. And you know what I kind of want? I want the paddles variables to be half height, half width. It's going to be much better that way. But we'll worry about that later. R times 2, R times 2. So there's a couple things here. One thing that I want is now in the paddle, in the puck, to check if x plus r, right? Because if its right edge is past the paddle's x, and not just past the paddle's x, but past the paddle's left edge, which is minus paddle w divided by 2. Oh, my kingdom for some clean, not so horrible long if statement. But let's just look at this and see if this looks nicer. Which key do I move it down? There you go. Oh, did that? That didn't look exactly right. Did it? I can't tell. It's moving so fast. Hold on. Oh, that's perfect. Okay, I saw that's perfect. Okay, so that's great. So that works for the right paddle. Here's the thing. I think what I need to, the problem is there's a little bit of an issue, which is that I want to check if the x is greater than the x for this paddle, but I want to check if it's less than for this paddle. So I think what I need is to indicate, because I could do some more sophisticated thing where it could bounce off either side, but it doesn't do that in Pong. So I might want to pass that function maybe a +1 or a -1, depending on which side of the paddle I'm coming from. I could also just write two different functions. I don't know what's best. But let's try my goofy way of giving this a number like direction. So this is like the direction it's coming from. So in other words, I'm going to check right. It's coming in the positive direction. I'm going to check paddle left. It's coming in the negative direction. So in that case, let's look. Can I do something like this? So I want to like format this in a way where I can kind of see it. Like these are the things I'm checking. If x plus r is greater than. So and this is, well, direction, this is minus. So I should really say plus minus direction times, right? Because I want to check on this side the x minus, but on the other side I want to check the x plus. So, and this needs to also be, this needs to be plus direction times r, right? Because r is, am I moving to the right of it or to the left, whether it's going, and then this has to become less than. Now, how can I turn a less than to a greater than with, I could just use the puck speed if it's going to the right or the left. That's a good point. How can I change this? So here's the thing. Let's just do this ridiculous way. So first, all right, let's break up this if statement. I don't like what I'm doing here. Let's just check these things first. Let's just check if the y is in between. So if the y is in between, which is just this if statement, then we can move on. If direction equals -1, then check the x value if it's less than. And I can actually just do this because I'm going to be lazy. Make it, right? I can check this, and I can put this as an and. If direction is -1, and so I actually don't need this direction. I don't need this direction because I can use the x speed. Okay, I got it. We're going to take this out, and we're going to say if x speed is less than 0, that's the -1 direction, then I'm checking it against the right edge of that paddle. And if that's the case, x speed times equals -1. Else, if x speed is less than 0, and now I need to just do the opposite thing. So if it's moving to the right, actually, by definition, it's moving to the right. Else, if, oh, camera went off. Time out, this will get edited out. Actually, no, it won't. Camera went off in the middle because the timer's still going. X plus r is greater than p dot x minus p dot w divided by 2. Then also, and I'm sure I could join these with an or. Oh boy, I made this so convoluted and complicated. But now let's think about this. This is very, very hard to read. This is not so friendly, but this is what we're doing. First, I just want to know, is the paddle's y position between the top and the bottom? Then, is it on the right side of the screen? Is it moving to the right or is it moving to the left? If it's moving to the right, check if it's gone past that paddle. If it's moving to the left, check if it's gone past that paddle. Let's see if this works. Oh, and I don't need this direction thing anymore. That was a digression that seemed interesting but unnecessary. And now, oh boy. Oh, look at this crazy, crazy puck, crazy Pong. Whoa, strange issues. It's just a flag with -1 or +1 and multiply. People, that's probably a very good idea. But what did I do wrong? If x speed is less than 0, there should be like a pause here for debugging. Okay, let me think about this. If x, the problem is I need to sketch this out while I'm looking at the code. Oh, this camera went off too. Sorry, everybody. Coding challenge disaster. Okay, wait. Hold on. Okay. Let me check this out, right? So x speed is positive. The puck's x should be greater than the paddle's x minus, the puck's x plus r should be greater than the paddle's x minus its width divided by 2, right? These are the points we want to check. If it's greater, plus x, puck x minus puck width divided by 2 multiplied by -1. Otherwise, if x speed is less than 0, that seems right. But really, here's the thing. Why have the same? The thing is, what did I do wrong? X times equals -1. What did I do wrong? Let's run this again. Oh, whoops, I refreshed the timer. That was totally by accident. Oh, it's getting stuck. So first of all, I'm panicking, everybody. It's getting stuck. Why is it getting stuck? X minus r. Let's just look at. First of all, let's treat these separately. Let's treat these separately. So let's just look at the right. Let's just check the right paddle first. What did I get wrong here? I need another close bracket. This is me debugging. So much for my timer. Okay, so why is it stopping? Because it changes. Oh, it's not updating. It's not moving off. So it's still there. Because where do I check? Then I show. Then I update. It should move though, because it's checking. It should get a chance to move. I mean, so if we just, I guess what I could say here is x equals p dot x plus p dot. I could just shove it. I could shove it off to the, wait. Oh, I'm on the wrong side here. This is the side that I want. What I could do is if it's moved past it, I think this is the same as the gravity bouncing ball problem. I could just shuffle it right to its proper spot, which is p dot x minus p dot w divided by 2 minus r. Oh. Oh, it's checking. Oh, this is like a terrible thing that I'm doing. No wonder. This is awful. This is like an awful thing that I've done. Because this is still like the right paddle. So it's still checking this. I can't actually do it this way with its x speed because I actually only wanted to check the paddle based on its direction. Oh boy, can I have a mulligan here? Can we edit this part out? I said I wasn't going to do it. So, this isn't going to be that short 12-minute. I'll do another version of this in JavaScript where I won't make these mistakes. Okay, I'm going to be really methodical. I'm going to unfortunately have to do a terrible thing that I wanted to avoid. Check paddle left. And that's just going to be checking. This is the right? No, this is the left. Check paddle left. So forget about this x speed thing. I have to check all these things. I ran out of steam here. And this is going to make this much easier. I was trying to reuse the same function. And I think I should just refactor this later after I think about it. Check paddle right. And then now we need to say if it is still within the paddle, but the x is different. And the x is x plus r is greater than this minus. So now we should be good. So now what I just need to do is I just need to say check paddle right and check paddle left. I just need a slightly different algorithm for each paddle and 2 different functions. That'll do it. Okay, there we go. Now, the other thing that people were saying is the angle should change based on where it hits it. Let's implement the score first. I've got 5 minutes. Somebody tell me so the angle should change. So this has to do with angle. So actually, no, never mind. I'm going to do something here. So here's the thing. Remember when I said I wasn't too happy about the way I created this initial speed? Well, I don't actually want to create a speed. I need the whiteboard here. Everything you ever want to do is more complicated than you think. If I pick a random x speed between like -5 and 5 and a random y speed between say -5 and 5, I could potentially pick an x speed of 0 and a y speed of 0. That's not what I want. What I actually want is to pick a random speed that's always maybe going 5, but is just in a random direction. So what I really want is a random angle between 0 and 360, or between 0 and 2 pi. And I have this other video. It's called Polar Coordinates. You can go look up that right now. Because if I pick a random angle, I can then say x speed equals whatever speed I want, like 5 times cosine of that angle, and y speed is 5 times sine of that angle. So this has to do with a right triangle and sine and cosine of that angle. And I go through the math for that in another video. Okay, so now what I'm going to do here is I'm actually going to take this out of here. I'm going to do this in the constructor because what I want to do is float angle equals a random angle between 0 and 2 pi. And I want to say x speed equals cosine of that angle. And I'm just times 5. And y speed equals 5 times sine of that angle. So now when we run this, we should see the puck always going at the same speed, but in a different direction. So the reason why this is important is because this angle thing, I think, is actually technically a variable that I'm going to want to keep track of. Oh, vectors, I should be using vectors. That's okay. We're going to be fine. Okay, People were taking bets on how long this was going to take me, and I think somebody is about to win. Okay, so now what can I do here? So now this should also, by the way, this algorithm should go in that reset function, which sets it back to the middle. And then, by the way, why not in the constructor just call reset? Now, I wish I could keep track of the angle and then I could just... Okay. Let's run this. I'm playing it. Okay, come on. This is pretty good. Hey. Kind of made Pong here. Oops. Whoa. Well, that's bad. That's a bug. Look at that. Okay, so I got to deal with, there's so many bugs. I shouldn't pretend, I should not have made that happen. Okay, so here we go. Let's at least add the score. Let's do something satisfying. I'm going to add score into sound. Okay, so I'm gonna say left score and right score. And I'm going to put those on the screen. I'm going to say fill 255, text left score, 10, I don't know. I'm just going to pick some location and text right score. And I should, width -10, something like that. Let's try that. So let's see if we get the score. Whoops. So you can see the score is there. I should make the font size a lot bigger. And then maybe make this in a different spot. Okay, you can see the score is there. Yay! Okay, now let's start adding some points. Where do the points increase? We're in the puck, the edges issue. If it goes off to the right, this is left score gets a point. And I don't love the fact that I'm using this global variable here in the puck object. I probably should return, and the score is really something, but just for the sake of quickness here, I'm going to say right score ++ here. So now, let's see if we can get some scoring going. 1, 1, 2 to 1, 2 to 2, 3 to 2. Okay, so we've got score. So in a lot of ways, we're in pretty good shape. Let's add a sound. Do I even have the sound library? Import sound. Okay, so what did I just do, by the way? Under Sketch, Import Library, I can go to Import Library, Import Sound. If you don't have the sound library, you're going to have to go to Add Library. It'll bring up this menu, search for sound, hit Install. Then you'll have the sound library. So I have the sound library. I'm going to say psound, I think is called. Ding. And then psound equals new psound. Ding.mp3. Maybe I have to say this. This. Ding.mp3. The timer went off. Oh my God, it's scared. Oh, can I have 10 more minutes, please? 10 more minutes. There we go. I knew this was useless. It's not psound, apparently. Let's look at the... why am I adding sound? This is really... Oops. This is really just taking up a lot of unnecessary time. Processing sound, sound libraries. I want to look at sound file. I don't know why I said psound. Sound file, file. I just imagined it was called psound. Sound file. And then, and let's just call it ding. And ding equals sound file. And then let's have it ding. Should we have it ding every time somebody gets a point? Ding.play. Ding.play. Okay, let's run this. Well, it's so loud. Is it loud for you guys? Oh, come on. This is like that thing in air hockey where it gets to the middle and you have to walk around and pick it up and put it back. Really, just while I'm testing the sound, and now you're going to bounce off of the puck? Okay, we can restart it. Can you guys hear that sound? Volume is fine, okay. Okay, so we've kind of got Pong. Here's the thing. Oh my God, stop. Okay, there's a couple things missing here, a lot. One is there's a bug that the ball can get stuck behind the paddle. So we should really deal with that. Number two is, I think I know how to deal with that actually. That's gonna be an easy one. Let's fix that. Because I'm realizing that what I'm checking for, really if it just gets past the middle of the paddle, right? So I think that's really the issue. The edges isn't really, it's really like the width minus, what is it called? Right paddle? Right? Minus right minus right dot W, right? And then this is left dot W. So I really just want to check, not if the ball gets all the way to the edge, but just a little bit past the paddle. Although, is that going to make it disappear in a weird way? Maybe, well, so maybe it's okay if it gets all the way to the edge. Oh, so maybe it's not about that. Maybe it's actually, so I don't like that because we want it to go, and it really should be if x, it should get all the way off the edge. If x minus r is off the edge, and if x plus r is less than 0, that means it's all the way off the edge. Now, what I really should fix is here where I'm checking the, checking this monstrosity here. Because what if it should only actually reverse its speed if, as long as also, I should also just double check, as long as the x is not greater than maybe the other side of the paddle. So not greater than p dot x plus w divided by 2. So as long as it is, right, because if it's already gotten, so it might get past the paddle further away. So as long as x is actually less than, it has to be greater, that has to be like really within the, within the paddle's bounds. So I saw starting angle, yes, the starting angle should be constrained. Okay, good point. X is less than, as x is less than the paddle's x, just say the paddle's x. Like it should be between the edge and its center. So this is like a quick extra double check to make sure it's not kind of behind the paddle. And this is another quick double check to make sure as long as it is greater than paddle.x. Okay, so let's try this. And now we should, okay, I'm going to constrain that angle. In reset, what we're going to do is we're going to constrain the angle between negative pi, 45 degrees, which is pi divided by 4, and 45 degrees, which is pi divided by 4. And so that will always give me something pretty much pointing to the right. But what if I want randomly to go to the left sometimes? So I can say, my chicken is ready, my tofu, whatever, tofurkey is ready. Okay, my toast is toast, that's what I was looking for. If x be, oh, this is horrible. If you've made it, hashtag ding, 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 if you've made it to the end of this. What was I doing? Oh yes, if random, 50% of the time, let's have it go the other direction. If random 1 is less than 5, let's have x speed times equals -1. So I'm always picking an angle between -45 and 45 degrees in this direction, but half the time it might go the other direction. Oh, I think I might have fixed everything. Oh, it looks like it's off, right? It's not. Look at that. So what's wrong here? Well, let's see if this side is right. Oh boy, I think I have my, Can I please take a break? I can't. I will finish this. So why is that off? It was working before. Let's look at this. Oh, I wish I didn't have this horrible if statement. I hate my horrible if statement. Okay. Stop dinging. Okay. Let's take this out for a second. Let's also just make the angle always 0. Just so I can test this. Did that mess something up? No. Okay, so something is woefully wrong. And is it bouncing in the right part here? It looks like it's a little bit off, right? Yeah? Okay, so let's see if we can figure this out. What did I screw up? Paddle, check paddle right. Let's check the paddle right. Okay, if y, okay, the y thing is right. It's the x. If x plus r is greater than the paddle's x minus p dot w divided by 2. That seems right. I have an extra speed minus 1. Where? Oh, look at that. Oh, no wonder. That's going to screw stuff up. Okay, I think it's working now. Is it just me that it's visually like, I feel like it should get a little closer. Oh no, it's working. Oh, it's just because it moves 5 pixels per frame. So it's always, it's, you know, it's sometimes not going to appear exactly, but that's right. Okay, now let's put this back in. What did this do? Let's make sure it's also within a certain range. Okay, that's good. Oh, it was working. I had that extra thing there. Now let's give it a random angle again. A random angle. Where did I do that in Puck? Let's take out angle equals 0. Okay, now we're going to play it. Here we go. Oh. So let's see if I can make that bug happen. Yeah, okay, that bug is gone. It's not getting stuck behind it anymore. So everything is actually done except for one big thing. The angle that it moves, the way that it changes should actually change according to where it hits on the paddle. Attention, Shiftmeister. Okay, that's a good way to catch my attention. Okay. Oh no, the timer's gonna go. That's like the 3rd time I refreshed it to 10 minutes. Am I like 45 minutes into this now? Oh my God, this is hilariously embarrassing. Okay, so I should do this in multiple parts, but I'm just not. I should just consider myself done, but I'm not. We're gonna finish this out. I need some ginger tea here. 48 minutes. Okay, I can at least finish it before an hour. You do realize I'm doing this live on a live stream with other people watching, with like lights on me, standing up in a very stressful mind. I'm wearing like a light up bow tie. Now we're just getting ridiculous here with this timer. Okay. All right. Oh, I walked over here. Why did I walk over here? So let's think about this. We're going to call, I think the title of this video should probably be Pong in 60 minutes, because I think it's going to be a 60-minute video. Okay, here we go. Now, here is the paddle, and here is the puck coming at the paddle. So what we're saying is, if it hits in the center, maybe it would reverse its x direction precisely and not change the angle. But if it hits closer to the side, it would then project further down. So we'd be rotating the angle by some amount the further down the paddle it gets. Is that correct? And same thing, but what if it hits up here? Would that cause it to also rotate further down because it's just based on the distance to the center? Or would that actually have it reflect further in? Which one is it? Somebody help me out. I don't know how Pong actually works. Like, is it always... Somebody tell me. Can we pause this video for a minute? I'm waiting for the chat. Thinking will waste time. Yes. Further in. What is the further in? What does that mean? Be more specific. Okay. Let me look in the code to where I need to do this. Depending on the movement direction of the paddle. Middle third is straight on. The paddle is like a circle, and the angle reflects the angle from the center. If it hits on the very corner, it should go in the opposite direction. Further at the top. All right, so if it hits further up, angle goes up. Hits further down, angle goes down. Reduce the angle. Incoming angle doesn't matter. Top is reflect up. Top third ricochets up. Divided into thirds. Okay. Here's the thing. I'm trying to avoid actually using the angle because then I'm going to have to get into tangent and all that stuff, and I should have just used vectors in the first place. Oh my God. Adam J. Austin, sorry, in the chat just posted a... does it actually just give you, where it hits, it gives you a specific angle no matter what its direction is? That's perfect. How do I Google for that? There's no angular reflection. This makes it so easy. Adam J. Austin, how do I Google that image? How'd you find it? Puck angle direction. Oh, that's not Pong paddle angle direction. Oh, this makes it so easy. Where is there a picture? Where's that picture? It came into the Slack channel. Can someone just tweet it to me at the coding train? Pong angle segments. Thank you. Pong angle segments. Okay, Pong angle segments. There it is. Oh no, that's in this one. This is one. Okay, this is totally manageable. Look at this. So here, this is so much easier to deal with because it doesn't actually matter what angle it's coming in. It just goes at that angle no matter what. So what I'm going to do is I'm actually just going to map the angle. I don't even need to divide it in segments. I can be fancier and have it be continuous. So I just need to take its y value, its y position from 0 to the bottom and map it between negative 45 and 45 degrees, or negative 135 and 135. Okay, let's do this. Okay, so where does it hit the paddle? Over an hour was the correct answer. Okay. This is where it changes speed. But now, forget about all this nonsense. All I want to know is I want to know the difference between I want to know its y location minus the paddle's y location minus, I really should have the paddle keep track of its top and bottom location so I don't have to keep calculating them all the time. But I want to know how far from the top is y. And then I want to have an angle. I can use the processing map function where I take that difference, which goes between 0 and p dot h, 0 to the top, right? It could be all the way at the bottom, or it could be all the way at the top, and map that from negative 45 to 45. And then x speed equals 5 times cosine of angle, and y speed equals 5 times sine of angle. And then I'm going to do the same thing for the right. The difference is I want the range to be between negative 135 and 135. What did it say in that? I might have to rethink. I probably have to rethink these angle values because I have computer graphics window and angles point down. And also, hello, radians, people. Radians. Let's just convert this to rad equals radians of 45. So I want to go from, I could do, it's pi divided by 4, but I don't feel like, and I'm sure this is wrong. Radians 135, negative rad to rad. Okay, let's just throw caution to the wind here. I'm sure it's wrong. Yeah, okay. So first of all, you can see how I have it, it's going in the other direction. So this one should actually be 45. Stop dinging. Hold on. Does it still ding if I turn my volume off? Maybe not. Okay, let's try it again. That doesn't look right. Is that right? Or is it going oh, that kind of looked right. Is that right? That can't be right. Whoa. So I think okay. So it's clearly wrong. So let's think about, okay. Let's think about what these angles actually should be versus that diagram. I should never take a diagram literally. Okay. Okay, so this is the diagram. Let's just look at the left one, okay? And I can see what the problem is already. Oh, no. That's actually correct. This is computer graphics because the left one should be between negative 45 and 45. That's actually correct. Hold on. Because I was concerned that it's flipped, but if you rotate, or sine and cosine, all right, let's make a separate sketch to be sure about this. Okay? We're going to figure this out. 0 is to the right. 0 is to the right, but do sine and cosine, they do the actual math and they don't know about the axis being flipped, right? Or do they? I don't need draw, right? Because what I'm saying here is, let's do this. What I'm doing is I'm saying I have size 400, 400, and I want to draw a line from width divided by 2, height divided by 2. Let me just do 200, 200, 200, 200 to 200 plus x, 200 plus y. And I'm going to have an angle equal negative 45. And then I'm going to say x equals 100 times, okay, hey, stop, 100 times cosine of that angle, and y equals 100 times sine of that angle. Okay, so it's doing exactly what I thought it should do. Kill the timer, it doesn't matter anymore. Okay, so this is right. Oh, sine, no, sine should only do this for the y? I don't, Okay, so this is right. I feel like though that this is, so maybe my positioning is wrong. So let's see. So if it hits, so that's right. Let me go back to my other sketch. This is the left paddle. Okay, I got something wrong here. It's the mapping that's probably wrong, right? So this should be 45. So this should be 135, right? I had it right the first time because the difference, if it's at the top, y minus, the paddle's y minus, oh, hello. It's not, it's y minus the paddle's y minus that, right? That's the actual top location. That's the difference. That needs to be in parentheses. That was a big mistake, right? Because that's the difference. And it's kind of counterintuitive to me, but, right? And this is the same issue. Okay, so now, let's see what I get here. There we go. Yeah, doesn't this look right now? Oh, I feel so happy. Pong. Oh, wait, why did it have a bug? What was that bug? I don't like that bug. Oh, you know what the bug is? I know what the bug is. I think the bug, it kind of like skips past it because the paddle moves kind of fast. And I mean, the puck moves kind of fast. And this check is a bit of a problem. This extra check that I put on first so it doesn't get stuck. I think what I really want is, let's check as long as it's greater than, let's look at the right edge. So because sometimes it's going past, it's able to skip past that middle. Because it's only 10, I could make a wider paddle and then I wouldn't have this problem. That's probably what I should just do. Because my speed is 5, but I could also be, so let's just make a wider paddle. Let's make a wider paddle. Yeah, we're not going to have this problem anymore. I'm terrible at this. Okay, hey, I did it. It only took like an hour. Oh, watching the beginning of this video is going to be so sad. But this is Pong. My left hand, who's going to win, left or right? Oh, it did that again. Why does it do that? What's that bug? I think it's, oh, I know what the bug is. So actually here's the other thing I should do. If I want it to bounce off the right edge, it can skip over the right edge and be told to move back. But I think I should really, probably to be safe, I should always place it back to the correct location. So I should also say x equals the paddle x plus the paddle's width divided by 2. And here I should just shove it back, x minus equals the paddle's x minus the paddle's width divided by 2. I think this is also going to make it feel a little bit more accurate. 1 hour and 1 minute. There we go. Okay, I have to stop. Well, that was a little bit weird. I thought that was it getting stuck on it. Maybe I was still moving the paddle is the problem. Oh boy. Oh, I must have messed it up. I made it worse. Oh, I forgot about R. X equals, I want it to go on the right, also minus R. And I want this to also be plus R. This is going to be done. I swear this is done. If I had done this in JavaScript, it totally would have taken me 15 minutes. Yay, Pong. Okay, thanks for watching. I hope you enjoyed this. It only took apparently 61 minutes, and I don't know what else I'm going to do, but this video is over. If you actually watch this whole video, then I commend you. You are amazing. You are a part of my heart, and I will give you an internet hug and send you on your way. Goodbye. The stream is making me anxious. Hey, all right, everybody, before I go, somebody in the chat just said the stream is making me anxious. Oh, shoot. My soundboard's not working. Let's just take a deep breath, everybody. Okay, goodbye. See you soon. Bye-bye.